All right, today we're going to talk about the area of a square. Let me erase that. So because a square is a rectangle and a rectangle has an area, no spoiler alert, there it was. Because a rectangle has an area of length times width, you would write the formula like this. However, it's a square. So if all of the sides were example, 4, you could say 4 times 4. Or a more sophisticated way to say that is 4 squared, hence the name of the square. So if I want to find the area of the square, I'm just going to say that I take the side length and square it. So the area of a square is side squared. I'm not going to do all of these. I'm going to jump around a little bit. So for example, number 1, the side is 3, so the area would be 9. And then you're really squaring the number and the units, so make sure you keep the units squared. You guys are going to do 2. Number 3. Remember when you're squaring a radical, you're really doing root 7 times root 7, which technically is root 49, but the square root of 49 is 7, and then centimeters squared. You guys can do 4. Number 5. These are all squares. On a worksheet, it would have to tell you it's a square, but I forgot to put the squares in here, so it's a square. This is this part of the diagonal. Remember, a diagonal is bisected, so the other half is also 4. And now I can say that I have a 45, 45, 90 triangle where the length of the diagonal is 8. Remember, to get the leg, you're going to divide by the square root of 2. So that would be 4 root 2. So now you have 4 root 2 here, and then you're going to square 4 root 2. So when you're squaring this, remember you do 4 squared, that's 16. Root 2 squared is just 2, and so you get 32 centimeters squared. I'm going to leave this one. This one we've done before when we talked about 45, 45, 90s. Same thing. These you guys can do. Number 10, it says it's a square, and it wants you to find the area. So it does not give you any side lengths, but it does tell you that this angle is 120. So that's important because it means that the supplement is going to be 60. And now that you know that that angle is 60, you can look and see that you have a 30, 60, 90 triangle where the short leg is root 6. So the side across from 60 would be root 6 times root 3. Or root 18. Just for fun, this would be 2 root 6, but you don't need this for this problem. Now, normally I would say to break this down. If I wanted just the side length, I would break that down to root 9 and root 3. I would simplify it and get 3 root 3. Fine. But I don't necessarily need to write it like that because I want to find the area of the square. So now that this is the side is root 18, I can square root 18 to just get 18 inches squared. I'll leave that one for you guys. It's just talking about a square. A square room has side lengths of 12 feet. Andre's placing square tiles on the floor. They are 6 inches long. So for this one, just make sure you convert the 12 feet to inches. So that way you can work with the tiles in inches. And you guys can check that later. Okay. For a rhombus, I don't know if you've seen this formula before, but the area of a rhombus is not really based off of the sides, it's based off of the diagonals. So it's going to be 1/2 of D1 times D2. And D1 and D2 are not exponents. They're talking about the diagonal number. So diagonal 1 and diagonal number 2. It does not matter which one is 1 and which one is 2, right? 2 times 3 is the same thing as 3 times 2. So the actual diagonal number does not matter. Quick example, number 1. Again, it's a rhombus, so you have to remember the properties of a rhombus. It's not going to tell you that this whole thing is 6. It's going to expect that you know that it's bisected, so this is 3 and this is 4. That means that this entire diagonal is 6 and this entire diagonal is 8, and 1/2 times 6 times 8 is 24. Whatever, units. Squared. You put U squared. Doesn't matter. A rhombus has an area of 27. One of the diagonals is 8. What is the length of the other diagonal? So the area is 1/2 d1 times d2. The area is 27. 1/2 is part of the formula. One of the diagonals is 8. It wants to know what is the other diagonal. Well, half of 8 is 4. 4 times what is 27? Well, let's use a calculator. Or don't. 27 over 4 is 6.75. So D2 is 6.75. Remember, this is not an exponent. So do not do anything involving exponents. Diagonal number 2 is 6.75 units. All right, and then here is the last one. This is a doozy. This one's really fun, actually. So much fun. Math teachers always say that. A rhombus has an area of 15 yards squared. One of the diagonals is 4 more than twice the other. What is the perimeter of the rhombus? So let's just pause for a second. It's not asking you what the diagonals are. It's going to ask you what is the perimeter. So we're going to have to come back to this. And it's probably going to take a few steps after we actually get what we think the answer is. A rhombus has an area of 15 yards squared. So inside here is 15 yards squared. One of the diagonals is 4 more than twice the other. So you have 2 diagonals. You have D1. You have D2. And somehow when you multiply 1/2 times D1 times D2, you get an area of 15 in this case. So it's saying that one of them, so let's just use diagonal 1, is 4 more than twice the other. 4 more than twice the other one. So if you're already talking about D1 in terms of D2, you're just going to leave D2 alone. Now, this can get a little bit confusing because we are going to multiply these together because this is your new expression for D1. This is the expression for D2. So when I do 1/2 times 2D2 plus 4 times D2, it's going to get very confusing if I multiply 2D sub 2 times D sub 2. So can we just agree? Of course we can. That when we solve this, we're going to keep in the back of our minds that we have solved for D2. And so I'm going to erase the little sub 2 because it's not an operation, and I don't want us to get it confused with the exponent. Now, in this case, you can simplify easily at the beginning because you're taking half of 2 terms that are even. If these terms were not even, you would have to put it over 2 or work with some decimals. But luckily for us, I've made the problem where it's going to work out. So half of 2 is 1D, and half of 4 is 2. We're going to multiply it by D, and we're going to say it still equals 15. Now, if you don't like to see it like this, you might want to rewrite it so it says D times D plus 2. That's the same thing, but some people like to see it so that way they can draw their little arrows and distribute D to D. That's D squared. Now, do you see why I got rid of the D2? It would have been very confusing. Plus D times 2 is 2D, and that equals 15. I see an exponent. That means I should be thinking in my head that it's time to factor. So I'm going to do this over here. D squared plus 2D. In order to factor, you have to have one of the sides equal to 0. So I'm going to take away 15 from both sides, leaving the right-hand side equal to 0 and the left-hand side getting a negative 15 because that's the opposite of 15. I need the factors of 15. Again, lucky for us, there's not that many of them. 1 and 15 are not 2 away, but 3 and 5 are. And of course, D times D is D squared. I need the term in the middle to be positive, which means my bigger number has to take the sign of that. And boom, here we go. So D could equal 3 or D could equal -5 in algebra, but we're in geometry, and so D cannot equal -5 because that would be a negative distance. So that does not work, which means that in our case, D has to be 3, which we said was diagonal number 2. D had to be 3. So that's 3. Now, the other one is going to be 4 more than twice that, so twice that would be 6, and 4 more of that would be 10. So now the purple is 10. And just when you think the problem is over, remember I said it's not. We're going to try to find out what is the perimeter of the rhombus. And in order to do that, I need to... Let me not erase this because I'm going to post this for you. Trapezoids, that's next. Let's move that over until Thursday. All right, here we go. So we're trying to find the perimeter of the rhombus, which means that we need to find the side of the rhombus. You only need to do it once because it's a rhombus. So here's your rhombus. The diagonals are 10 and 3. And one very important property of a rhombus is that the diagonals intersect perpendicularly. And so if we bisect them to get 5 and 5 and 1.5 and 1.5, we can use good old Pythag to find the side length. Because it's just a right triangle. Boom, boom, bam, bada bop bam. Away we go. 1.5 squared plus 5 squared equals something squared. 1.5 squared is, what is it, 2.25? Let's check. 1.5 times 1.5. 2.25, wow. Plus 5 squared, that's 25, equals c squared. And so this is 27.25 is c squared. Now, normally I would say that we have to make this into a radical, but I'm not going to do that with this decimal. So we're going to take the square root of 27.25. Square root is about 5.22. So now that is the side length of the rhombus. You do not need to do any more finding out of sides because all of the sides are the same. It's 5.22. Wait, one more step. What is the perimeter? Well, it's just 4 5.22s because there's 4 congruent sides. And so it is 20.88 yards. There we go. So I have done the hardest of the problems. I'm going to leave whatever is left on this worksheet for you guys to just do in Google Classroom. Well, whatever. Where'd it go? So whatever ones I did not do, this worksheet's pretty simple. But that's the hardest that it's going to get. Now, what's today? Tuesday? Yeah. So tomorrow I'm going to post a quiz for you guys that'll be due on Thursday. And then on Thursday we might do something like a mini project. And then you guys will have off on Friday. So quiz on Wednesday. We'll talk then. But for now, here's the area of squares and rhombus.